Okay, this is a question about a continuous random variable that is uniform. Mr. Schweiger does not always let his statistics class out on time. In fact, he seems to end class according to his own internal clock. This might seem familiar. I think we had a test question that looked very similar to this. The density curve here models the distribution of y when the amount of time after class ends in minutes, when he dismisses the class on a randomly selected day, and a negative value indicates that he ended class early. Find and interpret the probability that y is between -1 and +1. Okay, I'm trying to let's pretend that those are evenly spaced. Between -1 and +1 would be this area. Okay, notice that if I think about this in chunks, there's different ways you could do this. The base of this is 5 units, and so that means the height must be 1/5. So one way to do this would be 2 times 1/5, like just find the area to find the probability. Also, you can just kind of proportionally think about it. 1, 2, 3, 4, 5, 2 of the sections, so 2/5 is my probability. So this would be like, again, it's a long run. So after many, many classes, the probability that he dismisses class between 1 minute early and 1 minute late is 2/5. What is the mean? Explain your answer. Okay, so normally to find the mean, we have to if we have a table, we do the thing where we do the number times the probability plus the number times the probability plus the number times the probability, like over and over. But for this one, it's uniform. And so that means the mean is just going to be right smack in the middle. So if I'm looking at this, because everything is equally likely, again, I've got 1, 2, 3, 4, 5 units there. Right in the middle is going to be right there, which is 1.5. So 1.5 minutes is exactly in the middle of the uniform distribution. That's what I would explain. Find the value of x that makes this statement true. Y is greater than or equal to x equals 0.25. Sorry, the probability equals 0.25. So I kind of need to think, it says greater than or equal to. So again, I'm looking at this picture and I'm wanting an answer that is 1/4. So I need to imagine dividing this into fourths. There's 5 things. So if I divide that by 4, that's 1.25. So I have to go over 1.25, 1.25, 1.25. Since I'm just looking for the greater than side, I'm going to go over 1.25 and go right there. So that's going to be 3 and then minus 0.25, so it's going to be at 2.75. So 2.75 and above is going to have a probability of 0.25.